Good afternoon, everyone. Welcome to our workshop on new products, new forest products on Global Forest Watch. And let me start with introducing myself. I am Myroslava Lesiv. I am a senior research scholar at IIASA. And this session we are organizing together with WRI. Here I have colleagues from IIASA. This is Evelina who helped me to organize this call, and the Zoom is set up this call. And also we have some of our forest experts who are also listening here to this workshop. And we will have also from WRI, we will have Elizabeth Goldman and Elise Mazur, also the experts and the leading, from the leading team from WRI. So this workshop will be mainly focused on the introduction of the new products that are already in Global Forest Watch, or that will be soon published in Global Forest Watch and will be open access. That's going to be the first part. Then we will talk about mapping forest management globally, the new product to come, and also at the end, the plan was to have the hands-on session on visual inspection of the current maps and feedback collection. Feedback collection is quite important for us because then we plan to use this to improve the preliminary versions of the map. So to start with, I would like to invite Elizabeth Goldman from WRI with her first talk. Please, Elise, you can share your presentation now.
Yes, thank you. Okay, can everyone see my screen okay? All right, thank you so much. So my name is Elizabeth, or go by Liz Goldman. I'm the research manager for Global Forest Watch, and I'm here today to present the Natural Lands Map, which we created and released with the Science Based Target Network a couple of months ago. I'm an author on the technical note for this data, but wanted to acknowledge the lead WRI authors who did most of the technical heavy lifting, Elise, Mazur, and Michelle Sims. Elise is on the call too, if there's any questions. And then other WRI colleagues, WWF and systemic colleagues who were collaborators on this data. This is a project from WRI's Land and Carbon Lab initiative, which is a geospatial data and research shop creating new data and technical solutions to support monitoring of all land and carbon. And we wanted to specifically talk about this data and the forest management map that Myroslava is going to present on after me, because this data is really critical for Global Forest Watch and our users. As you know, satellite-based data can determine land cover quite well these days, but once we get into land use, it gets much harder, right? So in the context of forests, this means we have a lot of good information on tree cover, but then further differentiating tree cover into natural versus planted forests and different management regimes takes a lot of extra work and is much more challenging. So that's why we wanted to present these today. We're really excited about these data because we think it'll really move the needle for forests and all natural land monitoring by helping people focus on areas that they really care about. So in this context, this presentation is going to talk about why we map natural lands, what is natural anyway, what is a natural land, and how we actually went about mapping these areas. So as we know, we are losing natural forests, grasslands, and savannas at unprecedented levels, primarily due to the expansion of agriculture. WRI often works directly with agricultural supply chain companies who actually have an influence and power to stop conversion from happening, but are sometimes hampered by a lack of key data and information that they need to actually see progress. And one way that we've done this work and supported these companies is by working with the Science Based Target Network. So the network is different from the initiative. The network works with companies to set targets for nature, including freshwater and land targets. And then the Science Based Target Initiative is focused on emissions. These are the targets. The first target is the one that we focused on, no conversion of natural ecosystems. But then there's other targets to reduce overall footprints of agricultural land, and then engaging in local initiatives to protect and restore land. But so that meant that the goal of this first target is to have zero deforestation and conversion of natural ecosystems in supply chains by 2020, starting with 2020. And this goal can actually go back further if companies had existing zero deforestation commitments, for example, then they need to do this to an earlier period. And a quick definition, that's check too, when we're talking about deforestation, I think that's fairly clear. It's conversion of forest to another land use. In this case, conversion, we're talking about conversion of non-forest natural lands into another land use. So the challenge of this goal in particular is that companies really need two pieces of information that can be difficult to obtain. We need to know where natural forest was in the year 2020, natural land and natural forest was in the year 2020, and where they're sourcing their products from. And so we focused on this first challenge and problem. And our solution was to make data that helped companies set baselines for measuring deforestation and conversion, which creates its own challenge, and we'll get into that in a minute. But so what are natural lands anyway? Luckily, the Accountability Framework Initiative actually has a definition for natural ecosystems. This is natural ecosystems are ones that basically resemble what would occur if there was no human activity in a given location. So looking at species composition, structure, ecological function, that sort of thing. And then they have a separate definition on forests and natural forests too. Here we see the forest definition, which is basically the FAO definition, which has components on height, canopy cover, minimum area, and being able to grow to a forest in situ. Some of these are mappable and some are not. And so that's part of the challenge, is how do we actually operationalize these definitions into data that can be used? And that's what I'm going to talk about next. How did we actually map these lands? How did we operationalize these definitions? So for the forest part of the data, we followed basically a decision tree. So, and we did this with the other land classes too, that I'll cover in a second. But for forest, we basically took the University of Maryland forest height data for the year 2020 and assessed it against a number of different data sets to determine if an area was natural or non-natural. For the forest height data, we looked at areas greater than 5 meters to meet the definition. And then we looked at the intact forest landscape data from Potapov et al. That's an excellent data set. We trust it. We wanted to make sure nothing was accidentally removed when assessing the data against other layers. So if that was in an intact forest landscape, and it met the minimum mapping unit requirement, it was considered natural tree cover. We also looked at tree plantations and removed those, and other land covers like cropland areas and built up areas to remove those as well. And to get a sense of the rest of the workflow, I'm not going to go through this in detail. I encourage folks to take a look at our technical documentation, which is available online. But we followed a similar workflow where we took a land cover data set from either the University of Maryland or IIASA World Cover and assumed it was natural, and then applied different data sets to remove non-natural areas at a global scale. We then reclassified wetlands, peat areas, and then importantly, we substituted regional data where appropriate, where we felt like there was better data available at a more local scale. So the global maps were replaced in certain areas. To get a sense of where that happened, we have a map here showing areas in the kind of dark black show where the data was completely replaced by Mapiomas data or other sources that we felt just had a very high quality land cover map. And then in many places in the hatched areas is where we took 1 or 2 classes to try to help the global data where there was a lack of information. This was typically for the pasture versus natural grassland classes where we used certain data sources to help with that distinction. And And through all this work, we managed to arrive at an operational definition of natural forests and also natural lands too, but focusing on forests here. You know, operational definition is essentially tree cover greater than 5 meters in height, more than 0.5 hectares, excluding planted forest grown for wood or wood fiber. And sometimes, again, the local definition took precedence because of the regional data. And we were able to remove tree crops, which can be present in tree cover data sets as well. So we were able to validate this map too. So this is the confusion matrix for the entire natural land cover. And Myroslava led this work. We're working on validating that actual natural forest class as well, since there's so much interest in that specific class within the broader land cover map, natural lands map. And that should be available in the coming months, that accuracy information. So with that, I'm going to wrap. Quick presentation today, but we're happy to answer any questions. And these are my email, Elise's email are here. Please reach out with any questions. And you can see the technical note online. We have a Google Earth Engine app where you can see the data. And we are getting ready to release the natural forest map on Global Forest Watch. In about a month or so, it'll be available on the platform as a visualization and in some of our dashboard statistics too. So with that, I think I'll hand it back over to Myroslava. Thanks.
Thank you, Elise, for the very nice presentation. And the next one on our agenda is about mapping forest management globally. So here I will start. So this is the work that we do in collaboration with VITO. And just to give you a little bit of a background, motivation behind this work. So as you know, land use information is very critical and even becoming more critical for different types of policies, for example, EDR. And there is really desperate need by many applications. And as already also Elizabeth mentioned, that there is still a lack of global land use map that would be of sufficient qualities. There are always some issues related that information is outdated or not complete, and also very often we are not sure about the quality. So some years ago, I already don't remember, perhaps in 2018, we started this work on developing the first ever global forest management map at 100-meter resolution for the year 2015. At that moment of time, we used a legend which was focused mainly on FIO classes, quite well aligned with FIO main forest categories. We use, as remote sensing data, we use properly imagery at 100-meter resolution. We had also collected training validation data sets that was collected by experts, but also we have run a few crowdsourcing campaigns. Methodology that we use at that moment, we had per biome models and we run random forest. Now what we are doing, our aim is to update this map and to develop a new version of the map, but for the year 2020, we are working on introducing more classes such as rubber and fruit tree plantations to be more compliant with current policies. And we use a different remote sensing input, which is Sentinel-1 and Sentinel-2 imagery. For this, we have been working on revising training data for the year 2020, adding more classes and also collecting information in low accuracy areas. And we are also working on testing new various models, including CatBoost. About the models, this work is mainly done by VITO, our partners, and they have been testing models based on Sentinel-1 model, Sentinel-1 data, just Sentinel-2 combined models. They have been also looking at global models versus models by biomes. They have been calculating various features. So this is still work in progress. And the aim is to decide which one will be the best, with which model we will receive the best quality. And in parallel here, we at IIASA have been working on training data. So we have been revising the published area training data set for the year 2015, in particular in the areas where changes happened. We added 2 more classes, rubber and fruit plantations, and now we are actually in the phase when we are collecting more training data in low accuracy areas, in places where actually there are some issues, the quality issues of the first version of the global forest management layer. To collect feedback and also to collect our basically training data, we use a Geo-Wiki tool. We use various sources of information, various very high resolution images coming from Google, Bing, Esri. We also use Sentinel time series information. We are also using Google Street imagery and so on. But the most important input in this case is expert knowledge, is knowledge of people, what is located everywhere. And this tool just helps to localize it really to be much more spatial, much more precise in spatial location. So just to give you a few examples, because that can help you while you are exploring the map. For example, this is an example of forest with low human impact. Those are usually forests, very often mixed, like looking heterogeneous from above, without no signs of human impact around, no roads, no humans, nothing. In contrary, managed forests, you will always see something happening around. You will see clear cuts, logging, roads, some activities. And usually it's also on the image below, you can even clearly see this is like some planted, intensely managed forest. Woody plantations are usually, like from visual perspective, is also very clear. And then of course we have rubber plantations. Rubber plantations, they may look similar to woody plantations, but they still have their particular signal. They're bushy and they also leave their deciduous. So this is something that, yeah, if you know the area and you have very nice street view imagery, you can easily recognize these plantations. Fruit plantations, this is the image, which are usually lower, and you can see all the time very nice structure, how the fruit trees were planted. So there is always a bit of space in between the trees. And agroforestry definition is quite broad, and it's, it includes trees, fruit trees on combined with pastures. It also includes typical tropical agroforestry areas, such as when you have big trees and underneath there is second layer of planted some maize or something else. Or tea, for example. So you can have some maybe rubber and below will be tea or coffee. We saw quite some of this plantation in Central America. And some final remarks before we move to Geo-Wiki. So we have this new forest management map. We plan to publish it in May 2025. The idea is that we will make the map and the training data, everything of open access. And we also hope that we will run the independent validation and the results will be ready by the end of the year 2025. Thank you. So that was introduction about Global Forest Management Map. And now the idea would be that we move actually to Geo-Wiki. If you would like to visually explore the maps, so they are of open access and they are available on Geo-Wiki. So what you will have to do, you will have to log in. First, if you are not registered, you first have to register on Geo-Wiki. Then you have to launch Geo-Wiki to log in with your credentials. Currently, I am already logged in with my credentials. And then you will be redirected to the default page will be, I guess, different. It's going to be land cover. You will see here on the left side, here in the corner, you will see various pages available for visual. You can explore and play, but what we are interested right now, we are interested in this Global Forest Watch products, and this page is called Feedback Global Forest Watch. So you can go to this page, and on this page, on the left side, you have various tools. I mean, I guess the most important for you will be section maps, where you have two maps uploaded. This is an older version of Global Forest Management for the year 2015 with the legend. And then you also have Natural Forests, the first version of the map. So here you can play around, explore these maps. You can zoom in. I guess it's always a very nice feature. You can play around with the transparency over here with the layers that you have. In the geocoding session over here, you can jump to whatever location you want. You can add lat long coordinates and jump to them. Yes, and then one important thing will be section for your feedback. By default, it's already global forest management map here, but you can also select natural forest if you want to provide your feedback on that map. You have show all. This is to show all the submitted feedback, or you can just have a look at your submitted feedback. Here you have a button saying start to draw an area, where you can, when you press on it, you can draw any polygon, whatever you want. You can press a test comment where you can write your feedback and then you can submit it. You can also have an option to download feedback, all the feedback related to these maps, or just your own feedback, what you were providing. We have additional tools. It's more for advanced users. I think it's more complicated here, but some of you who are familiar with NDVI and Sentinel time series, for example, you can also play around with checking, for example, NDVI profiles. You can click wherever you want. For example, I have selected this tool, NDVI vegetation profiles, and the information derived from different remote sensing products. So we have from Lancet, we have Modis, we have Probovi, and you can, over the whole time, you can zoom into different periods and you can analyze this information. So this is total NDVI if you want to close it. Then there is another interesting tool. This is Sentinel time series. Over here, the next one, it's because we don't always know. For example, if you go especially somewhere in tropics, like in Brazil, let's go to Mato Grosso or somewhere in this area where we have active deforestation happening. Like, for example, because when we are having this very high resolution maps, Google Maps or Bing, we don't know the date when we look like this. But what we can do, we can, for example, I'm not sure if this is the right location, but we can select Sentinel time series, usually like color infrared, and then you can see, because you have better reflection of changes or the processes that happened, and you can clearly see, for example, 2017. So you have time series, there were some fires. So, or you will see if there was some additional deforestation. I was a bit unlucky with this example. I don't see that there was some clear deforestation happening, but usually let me go maybe somewhere else to show you. So where we go? Let's go more in deep here. Many changes, but they are, I don't know why, but it looks like they are burning the fields from time to time. So I have a bad luck. So where were these massive changes? Maybe it was this area. Usually Brazil is fires, small fires, and yeah, you see changes happening. Yes, over here. And this is a fire area. In black, what you see is all fires, and we do some sea changes, which were, no, they were already gone. This forest was gone a bit earlier. But you can track some patterns. So I was again unlucky. I should have prepared this location. The only thing what we track, we definitely see, we see all of those massive changes. Let's see here, maybe we will see something over here. No, And here you see that, for example, this area, it changed. 2016, it was still forest. And here it's already gone. That's done some of these places. And I think it's smaller pieces, but yeah, some things are happening around and extending over this place, which was over here. You can see a bit of forest texture. That was still, yeah, here you see, yeah. So this is a bit some small scale deforestation happening in this area. Okay, so that was my short introduction to Geo-Wiki. We are welcome everyone to check it, to check the map, to provide your feedback, and looking forward to our next meeting, I guess, when we will be presenting already the new map ready.